Hello students, in this video we are solving question 5 from exercise 1b of chapter 1 rational and irrational number from Selina class 9 textbook. In this question they have given us a set of numbers comprises of variety of numbers. From this set we have to classify set of rational numbers, set of irrational numbers, set of integers, and set of non-negative integers. Now, for the first sub question, we are segregating or classifying the set of rational numbers. When we are saying that set of rational numbers, then they consist of all the fractions, natural numbers, whole numbers, integers, and terminating and recurring decimals. So, starting from the first number, which is -6, it is an integer, so it has to be a part of rational number. Next, -5, 3 upon 4. All the mixed fractions are also part of rational numbers. So, -5 integer 3 upon 4 is the next number. Negative of √4. Now, in spite of being a square root, we can write this as -2. So ultimately, this will fall into set of rational numbers. So negative of √4 comes under rational. Then -3 upon 5 is a negative fraction, comes under rational number. Next, -3 upon 8, again a fraction, so it's a rational number. 0 is an integer, so it has to be a rational number. 4 upon 5 is a fraction, so it's a rational number. 1, it's a rational number. 1 integer 2 upon 3 is a mixed fraction, so it's a rational number. Root 8. Root 8 upon simplification, we get this as root of 2 into 2 into 2. Upon pairing, we get this as 2 √2, which is a irrational number. So that will not be part of a set of rational numbers. Next, 3.01. 3.01 is a terminating decimal. So it must be a rational number. Pi is a fundamental fact that pi is an irrational number. 8.47 is a terminating decimal. So it's a part of rational number. Now, for the second sub question, that is for the set of irrational numbers. Now, by definition, all the irrational numbers are such that they are not rational. So, any number which is not there in the set of rational numbers will come into irrational numbers. So, as we have seen in the previous question that almost all the numbers are rational except for two numbers which are √8 and pi. So for the set of irrational numbers, we will be having only two such numbers, √8, comma pi. The set of integers. For question number 3, we are making set of integers. Now integers are perfect numbers, positive, negative, 0. So -6 is an integer. Next integer in the set is -2 or -√4. Next is 0. Next is 1, and that's it. Only these numbers are the numbers which are perfect numbers. Minus 6, minus root 4, which is actually minus 2, then 0, then 1, then okay, that's it. Next, we have to make set of non-negative integers. The set of non-negative integers. So, in this set, we have to include all the integers which are non-negative. Okay, so minus root 6 is an integer, but it's a negative integer, so we cannot take it. Negative root 4 is minus 2, we cannot take it. 0 is a non-negative number, and 1 is a non-negative number. So for set of non-negative integers, we'll be having only two values, which are 0, comma 1. Now you may be thinking that 0 is neither positive nor negative. So how can it be non-negative number? So understand this word very carefully, that non-negative doesn't mean positive. It means something which is not negative. And 0 by definition is not a negative number. So here we are not concerned with the number is being positive or not. Rather than we are focusing that the number is not a negative number. So if it is not negative, we can take it into our set. Alright, this was question number 5. In the next video, we'll be solving question number 6.